Okay, so this video is going to be an introduction to Module 4, Lesson 2. We're going to talk about solving systems of equations using substitution. This is going to be an algebraic approach. We won't have to have the tools that we did for our Lesson 1. We won't have to have graph paper. We won't have to have straight edges. We won't have to have technology. And this method will work when our answers are, decimals or fractions. And the solving systems by graphing, it just doesn't work for that situation. So the idea here is, because these equations are true at the same time, if I can solve one of my equations for one of my variables, like in this example, the second equation here already solved for y is equal to negative 5x. Because these things are the same, I can take that negative 5x and I can substitute it in for y in my other equation. And we'll have something like this. And our new equation is only going to have one variable in it. It just has the x in there. And so this is going to be something pretty easy for us to solve. We just want to get the x by itself on one side. X minus 5x is negative 4x. Divide. And we've got our x value. We're not done, because just like when we're solving by graphing, we are expecting ordered pairs for our solutions to most of these systems. So what we've really found here is half of our solution. It's our x value, right? We need to find the y that goes with that. How am I going to get that? Well, I'm just going to take this x value. I'm going to substitute it in for x in either of our first two equations. They'll both work, but to me, the second equation is much simpler, so I'm just going to plug in right there. My x value is negative 2, since I just solved that. That'll give me my y value, and so negative 210 is going to be our solution to our system. Okay, so a couple of important things to note here. We're going to have the same kind of special case, or the same kind of terminology that we use to classify these systems as we did in Lesson 1. When we have a single solution like this, okay, we're looking at a consistent system because it has at least one solution, and we're looking at an independent system because our two lines are going to be separate lines. They're going to cross in one point. Okay, so in the last one, we were really lucky in that one of our equations was already solved for y. That won't usually be the case. Usually you have to do a little bit of setup for a substitution to work out for you. So in this one, my first step, if I'm going to use substitution to solve, is to solve one of my equations for one of my variables. This one, to me, the top equation is by far the easiest. So I want to start up there. And I'm just going to solve it for y. I'm going to get the y on one side by itself. So I'll start by moving the 3x over to the other side. Get rid of those. Divide by negative 1 everywhere. Change all my signs. And I've solved that first equation for y. Okay, so now what I'm going to do next is I'm going to take this expression, since it's equal to y, and I'm going to substitute it in for y in my second equation. I'll have 2 times 3x minus 18, plugging that in there. And again, once I've made my substitution, what I should have is a new equation that just has one variable in it. We can solve that. So that's going to be our next step here. We'll distribute that too. Okay, and so this one, we're going to get a little interesting twist that we didn't see in that first one. Negative 6x plus positive 6x, those are equal to 0. Those are gone, right? So what I've got now is a statement that says negative 36 equals negative 36. All of my variables canceled out. This will happen from time to time when you're dealing with these systems, okay? And got to be able to make a correct conclusion. The question that you want to ask yourself is true or false? Did I get a statement here at the end that's true or false? And this one is a true statement because negative 36 is equal to negative 36, okay? So what that is telling me is that there is an infinite number of solutions to this system, okay? Because I got a true statement at the end after all of my variables have canceled out, okay? It's a special case in that case, and there's a couple of things that can happen. If your last statement is true, infinite solution set. If we were to graph these lines, what we would see is that the two lines are really right on top of each other. They're the same line, kind of in disguise, with some algebraic manipulation to change their look. Okay, we call this a dependent system. That's the kind of key term when we wind up with this true statement at the end after all of our variables cancel out, or when we wind up with a system where the lines are right on top of each other graphically. Okay, so for this next example, we've got an equation at the beginning here that's already solved for y. This is pretty nice. Now, one quick note, we're going to learn another method for solving systems of equations with algebra in lesson 3. And I think in general that the lesson 3 technique is a little easier. It's the one that I would use more often. But this is a good example of a problem that I would always use substitution on. It's really nice setup because that first equation is solved for y. So this is a method that I would use. I don't use a lot, but this is a situation where I do use it. It's because the first equation is already solved for y. And I can just immediately take this expression, y is equal to negative 2x, y is equal to 2x minus 7, and I can substitute it right in for y in our second equation. So we'll have a new equation with only x as my variable. So my next step then is to distribute my x across the parentheses. Sorry, one little mistake in my calculation here. This negative I wrote that down wrong. So I was not getting the right answer. I was trying to figure out why. If we get rid of that negative sign here, we're going to have much better luck. Sorry about that. We'll distribute that 4 across the parentheses. We'll have 8x. So apologize for that typo on my part there. Okay, and now if we solve for x, we want to try to get the x's on one side. So I'm going to move this 8x over to the other side. And so it's kind of similarly to the last problem that we saw, all of our variables are going to cancel out. So we wind up with a negative 30 on the left over there, negative 28 on the right. Okay, but unlike the last one, we had a true statement in the previous problem. This one, negative 30 is not equal to negative 28. We've got a false statement at the end here. Okay, so when you get something false like this, it's going to let us make another conclusion. And this is going to be one of those things you're going to have to do on the test. You'll have to decide whether there's just one solution like we saw in the very first problem, or whether there's an infinite number of solutions like we saw in the last problem. Or in this case, where we have a false statement at the end, all of our variables canceled out, there's just no solution to the system. Okay, if we were to graph these lines, what would happen is first line's like that, second line's parallel. They're just never going to cross. So there's no solution to that system. We call this an inconsistent system when it doesn't have any solutions at all. Okay, so hopefully that's enough to get you off to a decent start with this substitution lesson. Please let me know if you have any questions.